It will be in two parts. This chapter will cover it in two parts. The first part will be the theory, and then the second part will be the theory, the remainder of the theory, and the calculation, which is the mixed design. People who had already been to campus in terms of the first practical, they are familiar with whatever we will be talking about today, or at least they've been exposed. So it has to do with that as well. At any point, if you have any questions, please remember, you can stop me and ask a question. I need confirmation that you can see my screen, the shared screen. Please confirm. I cannot see your reactions because I'm on presentation mode.
Yes, ma'am, we can see it.
Hello, everyone. We're going.
Okay. Please. Okay, I'm sorry about that. Okay, I'm sorry for the delay. So like I said, the chapter that we're going to deal with is concrete. Concrete as a material that we use in civil engineering for construction purposes. It might be for buildings. In certain cases, they also use it for pavement as well, when we're dealing with roads. Also use it in sidewalks. So it's used for different things, dams. You already know the list, right? So we're going to look into concrete in terms of what is it, how the mix in terms of how do you get the correct mix, and how do you know in terms of the proportions of each and every ingredient, how do you mix and what guides you, how does concrete behave when it's fresh, meaning that when you just mixed it, when it hardens, and then maybe some time after you have placed it, and then what will happen. So we're going to look at concrete in that manner, everything that has to do with it, and then towards the end we look into concrete and we go into details in the ingredients of concrete. Concrete is made up of different ingredients, being aggregates, cement, sand, and water. Like I will always say, the cement, I always highlight that is the main. Not that the other ones are not important, but it is the main because it's the one that binds everything together. So in this case, it is our binder. It's the one that makes sure, or that ensures that everything at the end of the day, it's one solid particle. So the cement, in terms of when you're looking at concrete or the cement and everything that has to come with it, we have what you call a mortar, right? It's a new word that you're gonna learn. When we refer to a mortar, we refer to a mortar, and it is a mixture of sand, cement, and water. Please note that it does not have aggregates in it. So normally they will use it then to when they're building, they will use that between the bricks. That's what they use. And then we also have a paste, which is a mixture of cement and water only, right? So those are, especially the first one, which is the mortar. Please note that word is important moving forward. And when we come to aggregates, remember we said later we will deal with each and every ingredient in detail, right? Aggregates can be different sizes depending on what is available. The cement that you use will also be different depending um, depending on the strength that is required. Please forgive me a bit. Um, Remember, please make sure that your mic is always muted. We have a problem, but at the same time, I cannot mute you, all of you, because you will not be able to ask questions. So just please, on your side, please ensure that your mics are always muted unless you want to ask a question. So they say that concrete has different uses such as single-story and multi-story buildings, dam walls, bridges, and other structures. So it will depend. Like I was saying, in terms of cement, the cement that you use will be dependent on the amount of strength that you need. So, for example, when you go to the lab, you realize we use the blue and the black cement. How are they different? They differ in terms of strength. The blue cement is the one that you use on a normal, maybe just residential houses, depending on the strength that will be required as well. So the black cement is a little bit stronger than the blue cement, and then the uses will differ based on the amount of strength that you need. So the choice of cement is based on that as well. So there are reasons why concrete is considered the ultimate building friendly material. They list 4 of those. They say it saves energy through its insulation properties and its ability to store heat. Its production is environmentally friendly, not entirely environmental friendly. To a certain extent, it might be, but it does not mean that it's 100% safe. Or its production does not have any does not produce any pollution or something like that. So in terms of when they say it's environmentally friendly, it might mean that to a certain extent, but not 100%. It improves the quality of life, high compressive strength, it's fire resistant, it's moldable, impermeable, long life, and it has that resistance to chemical attack. When they talk about impermeable, it will depend on the mix design and whether it was compacted in the right way or not. Why I'm saying that we will learn about that. Remember, in soils, when we spoke about segregation, we spoke about segregation and explained to you, and we said segregation is a new word that we need to take into consideration and learn. In terms of concrete, the word segregation will also come, and you need to know when we're talking about concrete and we say segregation occurred, what do we mean, right? So in terms of impermeability, it simply means that water cannot seep through it. but it will be based on different factors as well. So there are properties of concrete that you need to take into consideration. We have what we call fresh concrete, and then we have hardened concrete, or a process whereby a concrete will harden, right? Fresh concrete, in this case, it's newly mixed and is still plastic. Sometimes they call it green concrete. So when you see the word green concrete, just remember that it refers to fresh concrete, and it means that it can be shaped and compacted. So it's in the stage 2 to 3 hours, right? You can still kind of play with it and shape it according to what you may need it to be. So if you want a rectangular column, you can put it in that. If you want a circular column, that's when you are able to shape it into your desired shape. Using formwork. We'll also learn what is formwork. Hardening of concrete. So concrete, once the concrete has set, so they use the word set or hardened. It depends on certain things: temperature, cement, and admixtures. One thing that you need to note about concrete is that it's a very sensitive thing, in a sense that when you are mixing concrete, you need to make sure that there are no any other foreign particles, especially in sand, that might give you problems. Or let's make an example. Even though you use sand, we have beach sand. You can't use beach sand um, to mix concrete, right? Or to produce concrete. The reason why, because it has high level content of salt. It will affect your concrete. Even if there's sugar in it, it will affect it. I think if it has sugar, if it has salt, it might harden, it will harden, but you will have problems. Normally, when you look at it, it will be whitish, and then it also affects the strength. But then if it has sugar in it, content of sugar, then it will not harden. So you need to look at those things. Also, if you're using water, is it clean potable water? What kind of water are you using? So you need to make sure that if you're using any ingredient for concrete, you need to make sure that it does not have any foreign content in it that might affect the strength of concrete. When they say it depends on temperature as well, the hardening process will be based on that. If it's too cold or if it's too hot, something like that, then it affects the time it will take to actually harden the cement and admixtures. What are admixtures? Admixtures we normally add. So let's make an example. Let's say you are you want to produce concrete, and you want to maybe cast the slab or whatever, right? But wherever you are, because of maybe it might be that you want to reduce or minimize kind of the rate of hardening, then you will have admixtures that will affect your hardening process. So if you want it to set quickly, like we said, it lasts in that green state or in a plastic state for 2 to 3 hours. If you want to maybe make sure or ensure that it hardens quicker, then you can use admixtures. So those admixtures, that's what they're talking about in terms of you use that to manipulate or kind of aid or help. It will help you in terms of getting the same results, but maybe instead of it hardening in 2 to 3 hours, or maybe you can extend that time by maybe 1 hour or whatever, depending on what you need, right? Properties of concrete as well. We're gonna look into moldability, workability, consistency, and the cohesiveness of concrete. What are we talking about when you're talking about moldability? So concrete, when it's still fresh, we said that you can mold it into different shapes. And we said that formwork is used to produce the desired shape. So remember I said if you want your column, so what you see on the picture is a column, right? So that's how they will construct a concrete column. They will use reinforcement. Those bars that you see there, those are reinforcement bars. They help with strength. Why? Because concrete is so you have compression and tension. So it will be good in compression, but not so good in tension. Then you have then the compression bars to help you with producing whatever it is that you may need, because at the end of the day, you will experience both compression and tensile strength, or maybe loading in that sense. So it has to have that strength to withstand whatever the pulling or the compression that might be happening. So they use formwork to mold it into different shapes. So the formwork is that wood that they have there. Then they will use it to, it will be shaped in whatever shape that is desired, and then they hold it in place, pour concrete, and then once, because it has a set time, right? So if they say they will leave it there, so they won't normally leave it for 2 to 3 hours. They will leave it there maybe for a full 24 hours, or depending on the amount of days that they will leave it there. And then when they dismantle it, they will wrap it with plastic or whatever type of curing process that they're going to use. So that's how it works. In terms of workability, remember we spoke about segregation in soils, and we explained it. We are also going to talk about segregation again here, right? In this case, it means that this concrete is permeable. The one that you see there, it's permeable. Why are we saying that? Because those voids that are exposing formwork, the reason why we want it to be impermeable is because of this. The steel bars that we use in reinforcing concrete, they can erode, right? So because of that, of rust, and once they rust, it means that slowly it's got, that steel is losing the strength because it's being eaten away by those the reaction that is happening between the water and the steel, right? So because of that rusting that might happen, it will affect the strength. So we want the concrete inside, so the steel bars, sorry, to be protected to a certain, to that level whereby the water cannot seep through. Therefore, they will be able to produce that strength that we need for longer periods, right? So I'm sorry. We know that buildings, everything that we build with concrete, it's not like it's going to last forever. It does not last forever. So everything, even roads, they have a service life. So if they say maybe we are building this and maybe it's going to be here for 100 years, 100 or 50 years, right? We know that it's not going to be indefinitely, but for that specific time, we need that strength that we are requiring from whatever. So in terms of the strength that is given by or produced by the steel bars, right? It gives us a certain strength. So we want to make sure that no foreign material, in this case, it will be water. So if there is the permeability, if the concrete is permeable, then we might have a problem. So even if we said this building might last for 50 years, you might find that we don't even make it to that, and then there's a collapse or whatnot. So those things, those issues are caused by something like this, the segregation. So when they talk about workability, they say that workability refers to the ease with which concrete can be handled and spread. So too little water makes concrete difficult to work. An excess amount makes it too runny, and this leads to segregation. The same way when we were talking about soils and compaction, it comes back. The workability of concrete depends on the amount of water that is added. It must not be too much, it must not be too little, because either or you have a problem. Concrete becomes more workable if the resistance to flow between the solids is reduced, right? So maybe if the question is, how then, if the water is this important, how do you ensure that you have the right amount of water that has to be added? That is done through the mix design. So when you are designing the mix, you design the mix, and it will be based on different factors. We will look into those factors as we move forward. But in terms of how do you make sure that the amount of water is correct, it's dependent on the on the on the design, on the mixed design, right? So they say that workability affects the compactability and moldability of concrete. Therefore, it also affects the final quality of the hardened concrete. Therefore, workability of concrete can be defined in terms of these two terms: mobility and compactability. Um, so mobility is the ease with which concrete will flow around obstructions such as steel and into the corners of formwork. Compactability, the ease with which air that is trapped in the concrete mix can be expelled. Remember, you don't want air, bubbles or air that will be trapped inside. Why? Because that will be the right it will be the same way water will enter, because it means that because it has holes in it, then it's permeable. So we don't want those bubbles, because at the end of the day, if the concrete hardens still with those bubbles in it, it means that it gives water the opportunity to seep through, right? So in terms of what makes concrete to be workable, it means that when you look into concrete and this property of being workable, you need to look at the mobility. It must not be hard to an extent whereby you can't fit it into into corners, right? So when you go into the lab, you'll see, because you also put it in molds. If your concrete is okay and your compaction was of a good quality, when we remove those molds, or when we remove them and we prepare to put them in water, it must be that it does not have any bubbles, um any inconsistency around it. It must be smooth, right? Because the formwork, because that cube, it works as a formwork, as a type of formwork to kind of guide us and tell us that this is the shape that you're going to get. You're going to get a cube of concrete, right? The molds are smooth, and they put oil in them so that it does not stick. The concrete does not stick to the mold, and therefore, because of that reason, the smoothness of the formwork, it should be that the shape that we get, or the final product that we get, it should be smooth. If it's not smooth, then it might mean that there was a mistake, either in the compaction, or it might have been the mistake in the mixed design. Then it means that there's a problem. Or sometimes when you are mixing, you remember those who did, when you're mixing, you're told that you should never ever lose any water, because you mix the concrete on top of a steel sheet. Sometimes you pour water and then it did not even interact with the mix, the dry ingredients. Then it means that you lost a certain percentage of that water, so that will affect as well. So something like that, you need to make sure that it does not happen, because it will affect the way the concrete will look. Not only that, if water is able to seep through it, it means that you have a problem. and the reinforcement will rust, and then you will have a problem. So what is mobility? So mobility, so they say that concrete with a higher water cement ratio will require less energy before it begins to flow. The more water in the mixture, the less the resistance to flow. I will show you a chart that I made so that you understand this better. In terms of compactability, to ensure that the hardened concrete reaches the required strength, air trapped in the concrete mix needs to be expelled. They use vibratory pokers to expel the air on site. In the lab, you saw that we had that machine that will vibrate the concrete to make sure that we expel any air that might be trapped inside. So this is what they're talking about. Remember here, high water cement ratio, what requires less water and whatnot. So when you look at the top one, so they tell you what happens when you have low water content, um, what does it affect, and what does it produce, right? So they say low water content, you will have poor workability, right? So it will be hard to work with that concrete because you don't have water in it, right? It will be difficult for you to compact that concrete, and therefore the strength that you're going to produce there will be low, and the durability will also be low. Low water content that has low water to cement ratio, it will give you high strength and good workability. Good durability. High water content will give you good workability. It will be easy to compact the concrete, and then it will produce high strength and good durability. High water content coupled with high water to cement ratio will give you low strength and poor durability. So in this diagram, what is happening is they're kind of guiding you and telling you, in terms of water, looking also at the water to cement ratio, because remember we said there are other ingredients, but cement is the main one. Why? Because it's the one that acts as a binder. So they tell you that if you take a certain route, then you're definitely going to get high strength. So they tell you or kind of guide you that when you want high strength and good durability concrete, whether with low water content or high water content, how will that work in terms of water to cement ratio, and how does it affect the strength as well? So if you have the high water content, and you have high water to cement ratio as well, it means that you're gonna go in the direction of low strength. But if you have a low water content and coupled with low water to cement ratio, then you are bound to get a high strength. So whether you want concrete that is workable or easy to compact, if you want it to be easy to compact and still get good strength, it means that you need to go for high water content based on the cement as well. So it does not mean that you just look at concrete and say, I want high strength and I want it to be workable, therefore I will add too much water. No, it's based on your mix design, right? So the mix design will kind of indicate. Sometimes it happens that you mix and you find that it's still hard. You will have the option to add a little bit more water, provided that you don't overload the mix with water. But if it's too, so what's happening is if maybe there was a miscalculation or there are other factors that affected your consistency, then you can add more water. But if you decide that I'm gonna work with the concrete as is, if it's hard, it means that it will not be workable because it will be difficult for you to mix. Therefore, it will be difficult for you to conclude that now it's consistent or it's homogeneous, in a sense that all the fines are mixed with water and then we have a smooth paste or whatever. It will be dependent on the amount of water added. So as much as cement is the main ingredient, also water is important to kind of maintain and make sure that you have the exact or the right amount. If it's too little, it creates problems. If it's too much, it adds it creates even more problems as well. So when they talk about the consistency, they say it refers to the stiffness or slopiness of fresh concrete, and it's most commonly measured by a slump test. What's a slump test? A slump test, it's a test that they use in concrete to make sure that your concrete will not, you see in cases of your segregation and whatnot, you look at the flow, right? So the consistency, when we talk about the consistency, we look at the flow of concrete. Will it be able to flow, yes or no? So if it's hard, it means that it will not be able to move. It will resist any movement. And if it has too much water in it, it means that segregation will occur. If it's the right amount of water, then you will get the right slump or the correct slump. So sometimes you'll have a collapse, the right or true slump. In your books, they also indicate you have a true slump, you have a collapsed slump, and you'll have a shear slump, right? So those are different types of slumps that you will get. You measure the slump, preferably, it depends. You will be told, we want a slump of 75, right? When you're doing your mixed design, then you will design for a slump of 75. If they want 100, they'll tell you they want 100, but mostly you will be designing for 75. So if they say we want a slump of 75, you will adjust your water. So initially, depending on the size of the rock that you need to use, aggregates, they will tell you if you're using 19 millimeter, maybe the amount that you need to add is maybe 210 liters. If at any point they say, but we want a slump of 75, then you will get a table whereby you'll have to adjust, either add or reduce the amount of water depending on the stone size. So all these different ingredients, they're interrelated in a way. So none of them is more important than the other because they kind of need each other to produce the strength that you require or the correct mix. So in terms of stones, the stones will be based on, because it's the most hard ingredient, then it will kind of give us the strength that we need, aided by the binder, which is the cement. But the cement alone is not a binder. When you introduce water, the water will react with the cement and then they will bind the stones together. So you see that's how it works. But cement alone cannot give you that result. That's why you need other finer particles that will be trapped between the solid particles to produce the right mix that is impermeable and is not segregated, and therefore will give you the strength that you require. So that's why I'm saying all the ingredients individually, they don't mean anything. Together, they give us the correct or the right strength, but the other ones are more important than others, but it does not mean that the other ones are not important at all, right? Because water is important, but you need the right amount. Cement is important, but you need the correct type, and the water to cement ratio needs to make sense for you to produce the correct mix of concrete. At the same time, without the aggregates, that strength will never be achieved, because the rocks or the aggregates are the ones that are stronger in that mix. So you all need them together to produce that. So in terms of cohesiveness, they say concrete is made up of different ingredients, and they all have different densities. Segregation also occur if the mix is not correct. This phenomenon will occur frequently in wet and very wet mixes, or when the mix contains too much fine aggregates. So separation of aggregates leads to bleeding and plastic cracking. For now, we will stop. We'll just do hardened concrete, but in terms of cohesiveness, we will come back to that, because that's when we will also look at the cracks that you are going to get based on cement. And when you are learning this section, remember to also remember that when we were talking about stabilization and we spoke about cement stabilization, we said that even when you're stabilizing soil with cement, you are bound to get cracks, right? Types of cracks depending. Even here, they also come back and tell you that because we have this, when there is a problem, you will have bleeding and plastic cracking. So bleeding is that process whereby when your mix is too wet or it has too much fines, they will tend to kind of maybe want to get out of the mix because it's too much. Therefore, there is no cohesiveness, and that segregation will occur. So if that segregation occurs, it means that the water, because it's runny, it means that all the fine particles will then go into a different direction, all the solid particles, because they're not able to follow. They're not part of the wet mix. Then it's a problem. So when they talk about segregation of aggregates, that's what they're talking about. In a, if you put it in a container alone, then you might be able to see it. If you in a formwork sense of view, those this picture is what they're talking about when they're talking about. So it means that here the consistency is not good. And even when you look at this one, this picture here, this one, the middle one, but at the top, when you look at that, you see how at the bottom, all the solid particles collected there together, and then the final ones are somewhere here. So this is segregation. It means that all the solid particles, then what they did is they collected at the bottom, and here you have a problem. So it means that this is not the right mix. So they tell you this happens because of an incorrect mix, and sometimes it happens if there are too much fines in that mix. So it will lead to segregation of aggregates and also lead to bleeding and plastic cracking. But in general, if you're using cement, because of the hydration process that happens when cement mixes with water, it will give off heat. That process, it will, because it will it means that it will move towards rapid hardening. That's why you need to put it in water to regulate that hardening process. So basically, if you take concrete, right, you prepare a cube. You prepare a cube and you just put it there outside, without putting it or curing it in water. And you take another cube, you mix them, same mix design, same everything, and the other one you cure. The concrete that is placed in water will give off more strength than the concrete that was not exposed to water or cured in water. Because of that, the hydration process happens quickly, and therefore quickly the concrete hardens, and then there is no strength gain. Right, in your books you'll see when we are in part 2, when we are discussing the hardening of concrete, you'll see that it happens gradually. It will increase and gets to its peak. Once it gets to the peak, then it will go and move as a straight line. It means that now the concrete has gained the maximum strength that it can gain, and therefore it stays at that level. What might make the concrete to reduce in the strength will be if the concrete that you produced, right, it was the right mix and everything, but the problem is the bars inside are eroding because maybe there was a crack, and then it means that if you try to test, you'll see that now the strength will reduce. But theoretically, so the strength will increase, get to the maximum. After getting to a maximum, it will be constant. The other thing that might lead to maybe strength loss and everything, it's if the building was there for too long and it's bound to deteriorate, because it's not like it will be there indefinitely. Therefore, but if in that case, it will happen after years and years and years. That's why also they speak about after you have the concrete, you will have a finishing process whereby you try to protect the surface of concrete, especially the one that will be exposed to environmental conditions, being the sun and water, right, in the form of rain and that. So for you to get concrete that is good and durable in terms of lasting, not forever, but to the year, to at least to the savers, to the savers that you wanted, maybe for 20 years, or to reach its savers life, right? So to reach its savers life, if it's 20 years, you need to have the proper mix. Make sure that you don't have any segregation. In terms of cracks, make sure that you maintain and try to make sure that you get as minimal as you can. At the end of the day, once you have that, then you need to protect the concrete so that any external conditions around it, it does not damage it as rapidly as possible. So in terms of properties of hardened concrete, they tell you that durability is the ability of hardened concrete to resist natural elements. Here they talk about rain, wind, sun, and others. So compressive strength is usually considered the most important property of hardened concrete. So concrete is stronger in compression than it is in tension. So that's why you will have those steel bars inside of concrete to make up for the tension that concrete does not have. It does not mean that it's zero, but it means that it's not strong enough to protect the concrete from failing. Therefore, it needs to be reinforced to provide that strength, right? So what did we learn today? We learned that concrete is material used in building. It might be of residential houses, mega buildings, retaining walls, dams, other pavement structures, concrete pavement structures, mostly used in rigid pavement, right? So concrete as it is, it's based on different ingredients. How do you make sure that you get the right amount of each ingredient is based on a mixed design. If it's based on a mixed design, what does too much water do? What does less water do? What do you have when you have a high content of water and a high cement water to cement ratio? Does that give you high or strength or low strength? That we learned today. We also learned that for you to have we learned that concrete has different properties. These properties are dependent on the mixed design. It has to be correct, but at the same time, just because you're afraid of too much water, it cannot be that you add less water. It has to be workable, right? You need to work with it. It needs to move so that it fits into all those corners, but at the same time, the water must not be too much so that you are able to get, in terms of in terms of flow, right? The consistency of concrete, it has to be the right one. Also in terms of cohesiveness, because those materials, they need to be bound together to create the strong material that you have. So all those things are dependent on all the ingredients of concrete. But the worst thing that can happen to your concrete is you having the wrong mix design, which will ultimately give you less strength. In most cases, you will get a problem like cracking or bleeding if you have too much water or too much fines in your mix. Then it means that already you have a problem. So for you to get the right concrete, what you need to do is to make sure that your mix design is correct. And in the process of mixing, you need to make sure that everything is controlled so that you don't lose any amount of water that may lead to problems in terms of the workability, the consistency. Formwork is it can be in wood forms whereby they will get the desired shape, however you want to shape your concrete. They use that to keep concrete in place while it's in the green state or in its plastic state. How does that last? How long does it last? It will last in that state for 2 to 3 hours. After 3 hours, you will no longer be able to work it. We also said that in terms of the ingredients, you need to make sure that they don't have any foreign materials in them. Why? Because all those foreign objects like roots, sugar content or salt content in the concrete will affect the strength and sometimes the hardening of concrete as well. The water that you're using, you need to make sure that it does not have high contents of salt in it or no salt in it at all, so that you're able to build or maybe produce the concrete with it. The sand that they will normally use, they will use river sand and not beach sand. The reason for that is because at the beach, high content of salt, but the river sand does not have salt in it. So you look into those things, and that's how you know that you have the best concrete, right? So moving forward, the next time when we meet, we will conclude on, we will look in detail on the cohesiveness of concrete. What do they say about the cohesiveness of concrete, and what are the things that we need to note? We will also look individually in terms of the ingredients of cement. So we said we have sand, aggregates, cement. So we'll look into those ingredients and hear what they say about them. Fine aggregates, large aggregates, or as they call them, coarse aggregates, cement, how is it produced, and all those things. And then finally, we will do a mixed design calculation. A mixed design calculation, it's a calculation that tells you all the ratios of concrete that you need to put. So if maybe one portion of cement, 2 portions of sand, and 2 portions of aggregate, all that. So in terms of that, we will look into that when we are looking in the second section. One thing that I also wanted to highlight is the strength of concrete, right? It's based on 2 things, right? So sometimes it will be based on ratio, or sometimes they will specify and based on a strength. What do I mean? Maybe you will be told the engineer will say, this is the mix we want, right? So they tell you, I want 1 portion of cement, 2 portions of sand, and 2 portions of aggregates. Sometimes they don't do that. Sometimes they say, I want 30 MPAs. How you get to 30 MPAs, it's up to you. But at the end of the day, what they want is when they crush that concrete, it must give them the 30. So it can either or. You will be told, I want this strength. How you get to that strength, then you will do your own mixed design that will produce that strength. Or sometimes you don't go through that. They just say, this is the design that we want, the mixed design. Make sure that your proportions are correct, and we know already the amount that we are expecting from that mixed design. So the strength or the mixed design will be based on those 2 things. So sometimes you will be told, create your own mixed design, provided at the end of the day, this is what we're going to get in terms of strength. Or they just say, here are the ingredients. Can you produce a 20 MPa concrete? And then you need to do it based on that. So that is the only thing. So please remember those key points, and then that is half of concrete chapter, and the other half will conclude with it next week. Do you have any questions? Any questions? Okay. I'm going to stop the recording.